Okay, I just want to spend a couple of minutes just to talk about some announcement. Over here, so today, the lab session is mandatory. Let me just explain to you what's going to happen. Make sure you arrive in time. I would suggest arrive even maybe a few minutes earlier. For example, if your lab session is 4 p.m., try to arrive there around 3:55, 3:56, the latest. Arrive there, have a seat, and then as soon as we hit, let's say 4 p.m., and then we have to reboot the machines. It will reboot automatically into lab test mode. Lab test mode, it will be the mode we will be running for all the lab tests for the semester. So the main purpose for today, for the first 20 minutes, is for you to rehearse a little bit to see how the lab tests feel like. You will be able to, once you log in using your EECS account, you'll be given some HTML page telling you the instructions. You gotta read through it. It will tell you exactly what to do. All you gotta do is open Eclipse, create some projects, do something there, and then you can open up the command prompt and then go to your source folder and then submit. Basically what you did for lab number 0. We want to make sure you can do it without our help. Otherwise, in the actual lab test, we wouldn't be able to help you too much. Okay? Do you have any question about this lab test? That's why I started earlier in case you got any doubts. But the bottom line, you must show up because we're going to grade this part. You're going to do in the first 20 minutes. Remember, you only got 20 minutes. As soon as the 20 minutes is passed, the machine will be rebooted automatically, which means you lose all your work. Okay? That's exactly what happened in the lab test. Okay? The only difference is in the actual lab test, you got 80 minutes as opposed to 20. Do you have any question for me for this mandatory mini lab test this afternoon? Question? Okay, we're okay, right? Okay, let me talk about the actual lab test next Monday. Okay, I sent to you over the weekend. So basically, there's a study guide already, so check your Moodle announcement. So several things I want to highlight to make sure you go over before next Monday. So there's a birthday book problem over there I would like you to solve. And the actual lab test has 2 parts. The programming part will be similar to this birthday book, similar, maybe a slightly different example. And then there's an encapsulation video over there I want you to go over quickly, just about how to use private, how to use public. I will also go over this issue a little bit later in the semester, but by following the tutorial, you'll be safe, at least for the lab test. And then there's also another video which is very important. I try to explain over there what's my expectation from you for the lab test. Basically, you will be given a JUnit test class with possibly 10 to 15 test cases over there, and that's it. All you gotta do is do exactly the strategy I suggested over there. You have to figure out exactly what classes you have to create and what methods you have to define. Okay, so go over that video there, and you will know what my expectation is. Here is the requirements. When you submit your code, the original JUnit test class I gave to you, together with however many test Java classes you created, they must compile together. Okay, if no compilation, it's 0. Okay, so I already made it very clear. So please, just go over that strategy there. If you don't feel very comfortable, you still got a week. Just come to my office hour. I'll help you get over it. Okay, and one final thing. The only thing that's not really stated in the study guide is the equals method, which I will cover today. Okay, I'm gonna update the study guide tonight once I cover the equals method, which is also an important topic. At the moment, if you're already reading through on the birthday book tutorial video over there, it talks about how you can define equals method. So hopefully it will make sense after today's lecture. Any questions? So these are just administrative issues before we go to lecture. Yes, correct. So for the programming part, you're supposed to be familiar with the birthday book example encapsulation. Okay, guys, any questions before I move on to the lecture? Yes.
How much material do we need to know, like before it's like the lab test? Like, do we also have to know like material from like Wednesday's lecture too? Or?
You mean so whatever I will stop today, that's it for covering the lab test one. Okay, so whatever I'm going to cover on Wednesday, I tell you what, it might be that there might be 1 or 2 small examples for the equals method, which I cannot completely cover, in which case I'll leave them to you for self-study, or I might just cover them just for completeness on Wednesday. But any new topic beyond equals method will not be covering lab test 1. Okay? All right, let's now go back to our discussion about JUnit test. There's only a few more points I would like to mention, and then we'll move on to equals method, which is quite a tricky topic. Not difficult, but tricky. Okay, so this is some code I would like to go over. Let me just pose a question to you. So now remember this diagram I drew last time. Let's just go back there. The state diagram. Remember this state diagram here I showed to you. From this diagram here, we know that even for a small counter example, like what we discussed last time, you need about 8 cases in total, right? We have done basically the boundary cases, this one over here we have done, and we have also done this one here, okay? What's left? It seems like we need 6 more test cases. For example, set the counter value to be 0, try to increment and make sure it increments to 1. No exception is expected. Similarly, set the counter value to be 2 and do a decrements, and then no exception is expected, and the value should be 1, right, after decrements. So now, I want to show you a way to actually, because you can kind of see there's a pattern over here, set the value to be something, increment it, and the value should be +1 or -1, right? That's kind of the pattern over here. So rather than writing 6 different unit test methods, we can actually just write a single one. However, there's a trick we have to apply, which we all learned from Team 22, which is loops. Every time you find that there's some repetitive pattern in your code, very likely you can factor that out into either a helper method or into a loop to generalize it. That's exactly what I'm going to show you. Okay. Now let's go over the code quickly. The code itself is not that complicated, given that you understood what we said so far. Okay. So that's the code. Okay. So now let's see that. Okay, let's read it together very carefully. It's a JUnit test method, and it's already made available to you. First of all, we need a test tag, and then we have a method starting with test. Then we say increment, decrement all together from middle values, which means we don't expect any exception to be thrown, right? And over here, the first line, we try to say counter C, which is the object we're going to manipulate throughout the test. Okay? Before I go to the loop, let's just see the big structure. Okay? It's always good to see what the big picture is. We have a try block over here, and then we have 2 catch blocks over here. The reason that we have this structure specifically is because somehow in the middle, we have to call C.increments. Remember, increment method might trigger, let me use a different color here. Remember, the increment method might trigger the value too large exception. That's why we got that corresponding catch block. Similarly, you can see over here we also have C.decrements, which might throw value too small exception. Okay, the big picture is like this. And then over here you can see fail and fail over here. Simply because in this particular test cases, even though we are trying different input values, but none of them should trigger any exception. That's why if there's any exception that goes to the catch block, we should fail the test case, right? That's kind of the logic we learned from last time. And now I want you to look at the loops. So let's just look at the first loop, and the second one is very similar. The first loop goes like this, okay? We start with the minimum value for the counter, and then we stay in the loop as long as it is strictly less than the maximum value, which means because we know that if the current value is maximum value, it will trigger the value too large exception. That's not what we want to test in this case. So basically we go from minimum, which is 0, until max value -1. 0, 1, and 2. Only 3 cases over here, right? Let me just write it down for you. So that means for this case, we are testing 0, 1, and 2, and try to increment from them. Okay, similarly, you can see this for loop over here. Let's use this color here. This for loop over here, okay, you can see we start with the maximum value. And then we stay in the loop as long as it is strictly larger than the maximum value. Oh, sorry, strictly larger than minimum value. So what values are we testing exactly? So we start with the maximum, so that means 2, 3, 2, 1. So we got 3 and 2 and 1. Right? You can see from 0 we can do increments. From 1 we can do increment. From 2 we can do increments. These are the only 3 possible cases we can do increments. Symmetrically, from 3 we can do decrements. From 2 we can also do it, and from 1 we can also do it. So these are the only 3 possible values for you to increment. Right? Sorry, decrements. Okay, we got increment, we got decrement here, and the only thing left is to set up the test. What we do is, in the case of increments, we say that before we do the increments, we simply capture what's the current value. You can call c.get value. And then we make sure after the increments, we have the current value plus 1 will be expected. And then this is the current value. Okay, for example, for the very first iteration of this loop, c.get value will be exactly the minimum value, which is 0. Right? That's the current value. And then after increments, if the implementation is correct, it's going to increment the value from 0 into 1. Right? Into 1. And then what do we expect? It's exactly the current, the c.get value before plus 1. So that will also give us 1. So 1 should be equal to 1. If the assertion fails, that means there's something wrong with your implementation, right? And then we do something similar. We also, for another for loop over here, we capture the current value, and then we say current value minus 1 will be expected instead, right? Any question about this code fragment here? Yes?
So for your search equals line, in this case, it's incremented to 1 and it's checking that it's 1 in this case.
Yeah. Okay. Exactly. So to be more precise, why don't we run it very quickly, just conceptually, okay? Let's say, again, let's talk about, what about just this loop over here? This loop here. For the very first iteration, the I value is going to be maximum value, which is 3. And then the second one is going to be 2, and the third one is going to be 1, right? 3, 2, and 1. For the very first iteration, what's the value for current value? C.get value, right? So it's going to be c.get value over here will start with 3. The reason that we'll start with 3, there's something I forgot to mention. Remember in the previous for loop, we keep incrementing, right? From 0 to 1, 1 to 2, and then 2 to 3. That's what the value will end up with from the previous loop. That's why. Okay? So now, from 3 over here, we're going to do decrements, which means the new value will be just 2. Right? That's all we expect to see. And then for the second iteration there, the current value will be 2 instead, right? From the previous iteration. Do a decrement, no, you were down to 1. And then 1 will be the current value for the next iteration. Do another decrement, you get 0. Right? That's kind of the pattern that we are asserting. Hopefully the idea is not too difficult, but I'll encourage you, once you understand the idea, try to write it from scratch by yourself without looking to make sure you really understand. Okay, any question before I move on? So this will be the last code example I will talk about, at least for this lecture, for JUnits. Okay? Questions? As you can see, we actually connect very closely about writing JUnit test cases together with exceptions. So this should be something you should focus on. I might ask you some written questions for the lab test.
Yeah, I would also have a 0. I column would also have a 0 in this, right?
Which one?
For your I, so you had 3, 2, 1.
Yeah.
Shouldn't it go down to 0 as well?
Yes, you should go down to 0. Exactly what I wrote over there. Yes, question?
For the second loop,
Yes.
why is c.get value 3?
Why is that? Okay, good question there. Again, the question is, okay, let me highlight that. Why? So let's say as soon as we start this particular line of the loop, the second loop. So now, as I said before over here, right in the beginning over here, c.get value will be exactly equal to 3. That's your question, right? The reason is, you can see in the previous iteration. First of all, we start with c being a new counter. So c.get value at this point will give you 0. Agree? And then we know that we start with the minimum value until maximum value minus 1. So which means we'll go from 0 to 1, 1 to 2, and then 2 to 3. That will be the last iteration. So that's why when we exit from that particular for loop, c's value will be, counter value will be exactly 3. This actually accumulated from the previous loop. Okay? Make sense? Good. Okay, guys, any other questions about this fragment here? Okay. It's simple. The main lesson to learn from this example here is you can definitely try to specify several test cases using a for loop, as long as you can generalize the pattern by yourself, right? Okay, after this, I'm going to talk about something called test-driven developments. So now you know how to write test cases using JUnit syntax. And I just want to tell you, it's like an overall picture. Why do we learn about JUnits? So there's certain thing called test-driven developments, which means you should really drive your code developments using tests. So this is my general advice to you. You shouldn't only write test cases in the last minutes or maybe the last activity for your developments. You should always try to interleave test writing and your code writing. So let's try to see some a flowchart over here, okay? Let's say you start with certain Java classes over here, okay? You're trying to define them. So for example, what you start with, you try to define the constructor. Let's say counter constructor, right? You do something over here. Just initialize that to be the minimum value. Let's say you do that. As soon as you're done with this, you can already write some test cases to make sure the initial value for the counter is minimum value, which is 0. You can already write it. So which means as soon as you got something that is executable, you don't really have to finish implementing all the methods before you can start writing your first test. You can write the first test as soon as your code becomes executable. So now let's say we have got this constructor over here. You can already derive the test cases. For example, you can say counter C is assigned to new counter, and after that I can say assert true. And then over here I can say C dot, let me say expected value will be 0, and then C dot get value, for example, like that. Okay, so you can just keep doing this. And now this another picture over here, extend or maintain, which means every time, once you run your JUnit test cases, you got a green bar. It doesn't mean it's the end of your code development. You should keep extending the functionalities of your Java classes, which means you might add more methods, you might fix some bugs, or you might change something. As soon as you change something, you should always rerun over here. So this rerun part is the most crucial. As soon as you do some changes to your software, let's say for the lab number 1, part 2, if you change the way you implement the transpose method, then that means you should really rerun all your test cases. Make sure it doesn't suddenly become a red bar. If it becomes a red bar, that means there's something wrong you have introduced. Okay? So you got to rerun all the test cases and then using JUnits, right? You want to make sure you get a green bar. Okay? And of course, if there's anything that's wrong, that means a red bar. You should go back to your code developments and fix the bug, and then rerun all the test cases again. Okay? So that's kind of how the process goes. So keep this process in mind, and you should really notice that, as I said before, the confidence you can have from your test cases depends on the quality of your test. You should always think to yourself, have I really covered all the input value that are possible, or at least those boundary cases? Make sure. Okay? But so far, we simply just give you the test cases. But I think that for later labs, or maybe even for the exam or the tests, we might want you to write some test cases. Okay? So that's something we'd like you to practice. So what's the best way to practice? I would suggest go back to lab 1, part 2, matrix, or even for future labs. Whenever you assign some person task, in addition to the test cases we gave to you, I would suggest try to write some additional ones by yourself and try to think to yourself why the additional task can test a different perspective of your software, and show them to me, and then I can give you some comments. Okay? That's something I would suggest you do. Okay? And test-driven development doesn't really end in 2030. When you go to future courses or you go to work, this is something that that's really practical for you to apply. Okay? Always write test cases. Okay, any question about this? This one just about concept, about test cases. Of course, what we have focused on so far is how you can write the JUnit test cases, right? How you can translate it to the JUnit syntax. That's also crucial. You should know how to express your ideas using JUnits. Questions before I move on to equals method? Questions? Yes. Oh, didn't see him. Yes, I can. The question is the difference between assert true and assert equals. I'll just explain in principle, but we also see more example today. Okay. Let's see over here. Sorry, not photos. I want a new page. Add page below. Okay. The question was assert true. Let me just talk about assert true first. Assert true is only going to take one single value over here, right? And that one is going to see whatever expression you put over there must be evaluating to true. For example, I can say integer I equals 1. Integer j is assigned to, what about 3? In this case, I can put I equals j over here. Okay? In that case, it should be false, right? Because this is going to be false, so it's going to fail this assertion. And an equivalent way to write this would be, I can say assert equals. Assert equals, you can simply put one value on the left-hand side and the other value on the right-hand side. You can see the critical difference over here is, you can see there's a comma over here, right? For the assert equals, you got 2 values expected. But for assert true, you got only 1 value expected, right? So about the equivalence. The complication, which will be nice transition to the equals method. The complication is about the assert equals over here. When we talk about primitive values, like integer over here, or Boolean, or character, or double, okay? When you say assert equals, this comma here, you can think about just like an equals, right? That's how we compare primitive types. However, for reference types, it's a little bit tricky. Let me just give you one example. If I say assert equals over here, okay, and then let's say I got person P1, and then also P2. Let's say I got 2 objects, P1 and P2, and somehow they have been initialized to certain values. If I put P1 and P2 over here, it doesn't really mean, it does not simply mean P1 equals P2 directly. It might mean that, but not necessarily. Okay? So there are 2 possibilities over here. Either this or P1 dot equals P2. So that's the complication we're going to cover in the lecture today. Okay? But at least you should really get clear for the assert equals, if both values are simply primitive, you're simply comparing their values like this. For reference type, follow the lecture today. Okay? Is better? Okay. I did? Okay, maybe there was a typo. Which one? You mean in the iPad? In the slides? Assert true. Oh, I see what you mean. That's absolutely right. Okay, so here, you're right. So what I should have written, so that's wrong. Assert true 0 equals c dot get value. I think that's what I meant to say. We can say assert equals and then the 2 values. Yeah, good. Yeah, thanks for pointing that out. That was good. Okay, let's now talk about equals. Before we talk about equality, let's review certain basics just in one slide. And then we'll see how things might work differently. Okay? Let's recall what we did as a review. Okay? We have primitive types which store just the value. As for reference type, we store addresses. Okay? So now if you say double D1, 7.5, double D2, 7.5, they are the same values but different copies, right? Different values. Well, the same value but different copies. That's what I meant. Okay, but for reference, it's going to be address, right? So now when you say point, let's say we have a point class, P1, and P1 is storing the address of some newly created objects, so P1. And we also got P2 over here. It's simply just assigned to the address of another new objects. Now, if I say P1 equals P2, we know pretty well it should be false, right? Because they refer to different objects in the memory, okay? So now, let's talk about equals just for now. So that's what we have known so far. Let's summarize to know the difference. The equals, when we talk about primitive, you simply compare the contents for the integer, the contents for the Boolean, or the contents for the character, right? Just their values right away. So when you say D1 equals D2, it will just be true, right? On the other hand, reference is a little bit different, even though you also use equals. In this case, if I say P1 equals P2, that means are they referring to the same memory location? In this case, they are not. So that should be false. Okay? That's what we have known so far. Okay, any question about this before I move on to the new stuff? Okay, now let me give you a little bit like a roadmap over here. Basically, for the whole lecture, at least for the most of the part, I'm going to use the point example with x and y for illustration. However, to really illustrate the equals method, I'm going to create two versions of the points. I'm going to call them point V1 and also point V2. So just notice that there are two kinds of point classes for this lecture. Okay, I want to just warn you about it. Don't get confused. Okay, let's see the first version over here. Okay, let's have a look. Oh, actually, before I talk about it, let's talk about some background. Okay, I'm going to also show you some iPad page to illustrate the idea. So implicitly, okay, this is the class you should know when you program in Java. There is a class called objects. So this is a class name. You can definitely search for the API for that. Okay, so now when I say every class is a child or subclass of the object class. Okay, subclass and child class. Simply imagine that it's simply like a special. Every class that we have, like a person or string or like a points, is like a subclass, which means we accumulate certain code from the object class. Okay, that's what I would say for now. Okay, I'll illustrate what this really means, but we'll talk much more about this inheritance after the reading week. Okay, but for today, we just talk about object class. And the object class is simply symmetrically is the parent class and superclass of every class. We'll see the diagram in just a moment. Okay, so now today, so everything that's available in the object class will be accumulated to every class that we define, especially for today, the equals method. Okay, I want to show you this equals method over here all together with you, and then I will show you some code example. Okay, so we talk about the equals method over here, the equals method. And there's a class name called objects, always capital. Okay, so we're going to talk about two cases for today. So case one and case two. Okay, let's see the case one. You can see object class is over here, and usually we use this arrow over here to say that a class is simply a subclass or a class accumulates something from another class. Okay, specifically, you can see that over here in the object class, there is a method called equals. Okay, just a method called that. By default, every class that we define will accumulate or inherits or extends. That's a Java keyword, extends, but we'll worry about that after the reading week. So every class is implicitly a subclass of the object class, which means the equals method will be implicitly inherited over here, implicitly by default. Okay, that means every reference type you can simply say object1 dot equals object2. Okay, that's the first case. And in the first case, you can see that for our first point class, point v1, we do not try to redefine that equals method. Okay, what do I mean? I do not try to redefine. First of all, let's have a look at this. So this is the equals method in the object class. That's how they define it. Only one line implementation. Let's have a look at that very quickly. And now you will see why it is default definition. So this is exactly from the object class. Okay, exactly from here, the equals method. It returns a Boolean. So what does it return? It returns this equals other. Okay? Let's see, for example. As I said before, point V1 does not try to override or does not try to redefine the equals method, which means, let's say we got point V1, we got P1 and P2, two objects over here. So P1 and P2, their types are over here, which does not explicitly redefine the equals method, which means when you say P1 dot equals P2, we have to know which version of the equals method is going to be called. In this case, the equals method would be exactly this equals method because we did not explicitly override it. So now, can we just review what we did in the first lecture? When you say P1 dot equals P2, by applying this definition of the method, what does it end up with checking? The addresses of the object, exactly. As you can see over here, very good. So now let's see that very quickly. You can see P1 over here is a context object, agree? So that means that this over here will be replaced by P1. And then P2 over here is the argument, which is other, and that's P2. So that means other will be replaced by P2. So that means the default version over there for the equals method that's defined in the object class is only comparing the references of the context objects and the input objects. That's what they're doing by default. That's case number one. I'm going to show you in just a moment. But let me just go over the two cases with you. As long as you understand the roadmap for these two cases, we're pretty much done for today's lecture. Okay? The rest will be just filling the technical details. Case number two. We still have the object class over here. Okay? And the same equals method is defined over here. It never changes. Okay? So now, by default, we know that point v2 should inherit or accumulate this equals method. However, let's say we chose to define a specific version of the equals method for point point v2, because we don't want to say 2 points are really equal when their addresses are equal. We want to say 2 points are equal if their x and y coordinates are equal, right? That's something we want to define. So that's exactly the equals method we can define for us as a programmer. Okay. So now in this case, when we say P3, okay, here's the P3 and P4, and they are of version 2 of the points, right? And now when we say P3 dot equals P4, which version will we call in this case? This version here. And not this version up there in the object class anymore. Is the picture clear over here? I'm going to show you technically how you can achieve that. Any question about the diagram, first of all? Let me recap before you ask the question. So there are two, the bottom line is, because the object class is so-called a superclass of every class, that means every class that we define in Java automatically accumulates a method called equals, always. That means the equals method is always available to any reference type. However, you got to be cautious about which version of the equals method will be called. It can either be the default version or the customized version that you define. Okay? Case number one talks about the default version, where for your particular class, you do not try to redefine that. In case number two, you really try to do it, in which case, the difference really is, when you say P1 dot equals P2 in the first case, it's going to call the default version. In case number two, it's going to call the redefined version, the most specific version, basically. If it is redefined, call the redefined version. If it is not redefined, call the default version. Anything unclear to you, please, for this page here? It's important to get a concept straight before I show you the code. Yes?
Since dot equals is basically like compare all the things, then why still do we use two equals sign?
So the question is, if dot equals can actually somehow we can customize it to actually compare the contents of the object, why do we need equals? I would say when we talk about composition versus aggregation later, so equals is to check to see if the two objects, the variables referring to the same objects. So sometimes aliasing would be efficient for OOP. I would say both are useful for different aspects.
So it's basically.
You just want to support different kinds of comparison. Sometimes you want to compare if they're the same objects. Sometimes you want to say they are different objects in the memory, but they have the same contents, different. Okay. Yes?
What would be the answer to P1 equals
P1, say that again.
P1 with 3 equals P2, because there's an operator, right? 3 equals?
3 equal.
Yeah.
What do you mean 3 equals? You mean P? Actually, I've never seen that. Whoa. What do you mean? You mean? Well, you're saying P1 equals. Wow, really? Okay, maybe I didn't know so much. Oh, JavaScript. Oh, thank you. Guys, take my advice. Forget about JavaScript for this course. Please. I made the same comments last year. It's going to give you just trouble. Forget about it. Okay? No. But thank you for bringing that up. Yeah. Anything about JavaScript, forget about it. Okay?
So in this case, Professor, since you have the equals pointed to these two, how do you avoid the confusion of
Okay, the question is, okay, guys, let me just make one more remark. The question was, in case number 2, as you can see, there are 2 versions of the equals over here, right? You can see equals here, and also equals here. How can Java runtime know about calling this version over here? Okay, let me give you a very quick answer here, but it may not make too much sense. It all boils down to what object you're pointing to. Because P3 is going to point to a point v2 objects. So Java runtime would see, oh, this is what you're dynamically pointing to, so I will just go to that version there. So there's an automatic management in the runtime. So that's the part you don't have to worry. But has something to do with polymorphism, dynamic binding, which we will talk about after reading week. Okay. Okay, if no question, I would like to talk about Eclipse. Okay, let's see how we can prove our theory. And I want to show you how debugger can also help us understand. Okay, for the rest of the slides, for this slide here, you can understand. Okay. So now let me just go to Eclipse over here. I'll also make the source code available to you. Can we look at version 1 very quickly? As I said before, version 1, it's a point v1, which has only 2 attributes. And also we got a constructor. You can see that's it. There is no explicit redefinition for the equals method, no. Which means whenever we say we got point v1, let's say 2 objects, p1 and p2. When we say p1.equals p2, it is going to call the version from the object class up there. Okay? Let's see, let's prove that. The way I prove this is by writing a simple tester and show you. You can see I got point v1 and point v1, and then I got p1 and p2, right? Okay. So now what I want to show you over here, so for these printout, it should be very easy to see there are different addresses, okay? I want you to focus on line number 18 over here. When I say p1.equals p2, right? First of all, it will compile because equals method is always available to any reference type, okay? At least you got at least one version that's available there, which is default version. So now the question is, when let's say I put the debugger, I'm going to show you in a moment. If I pause my execution in line number 18, and then I say step into, right? So which version of the equals method would it step into? The object version, right? Because apparently in the point v1, there's no equals method there, right? Let's have a look to see my point. Okay, so now I already put a breakpoint over there, and then I'm going to say debug. Let's see exactly what's going to happen. Okay, let me just move this down a little bit. Okay, can you see that over here, line number 18, this is where I'm pausing. Okay, now I'm going to say step into it. As soon as I say step into, watch what's going to happen. We expect to see there should be the object class, which shows us the one-line implementation like this. Just like that. Just one-line implementation. Okay, let's verify that. Okay, over here, I say step into, over here, object.class. And then we are calling exactly this equals method. Everybody see it? Okay, that proves our theory to say because point v1 did not redefine explicitly the equals method. So when we say p1.equals p2, it is going to call the default version from the object class. In this case, it's simply just going to do this. In this case, this is simply just p1. And obj over here, as explained before, is simply p2. And compare to see if their references are equal. In this case, they are not equal, right? They are different objects. Okay? And then, so that's why you will see if I say step over, after this, you will see that it should be just false. Okay? Now, our goal really is we want to somehow to have some very useful redefined equals method which will compare every point by their x coordinates and y coordinates. That's something we would like to redefine. But how do we do that? Okay, let's see how we can do it. Okay, let me just stop here for the debugger. Let's see what else the slides want to say, and then I'll switch back to Eclipse soon. Oh, there's a common error. Okay, hopefully this already can spot as an error. What's wrong with this? Integer I, integer j, same value, I dot equals j. What's wrong? Oh, does it compile? Okay, does it compile? I'm pretty sure you know. Yeah. Yeah, exactly. That's exactly right. I and j, especially I, if you think I should be a context object, it cannot be because I is primitive. So this doesn't make sense. Okay, very good. Hopefully you can see that. That's a different story. All right, compilation error because equals method is only applicable to reference types. Okay. Okay, that's why you should write I equals j. Only the equals operator is applicable to primitive types, not the equals method. But for the reference type, you can use equals to compare addresses or dot equals to see what's going on. Okay, it depends. Okay, so that's about point V1. Okay, we have done point V1 already. I would like to show you, okay, so now before I talk about equals method, let's talk about requirements. When you define the equals method, there's certain requirements you would like to follow. Okay, I'll show you the source page for you to look at. That's actually from the authoritative guide for Java API. Okay, let's just go over them. They're not complicated. I just state it a little bit more formally. Okay, first of all, when you say x dot equals null, okay, it should never be true. It should just always be false. Okay, can you see why? Let me ask you this. Okay, my question is, x dot equals null over here, right? I'm saying that x is, oh, what if x is null? Yeah, question. Yeah, which means you don't even get a chance to evaluate it, right? If x, the context object happens to be null, then you just cannot say true or false. You just get null pointer exception. So that means x, the context object is not null, compared with some null object. Of course, they are not the same. Doesn't matter how you compare them. Okay, that's the first principle. And for those of you who haven't seen this operator over here, that simply means not, logical not. Okay, in case you haven't taken 1019. Okay, this one should be quite straightforward to you. If I compare one object with itself, equal, always the same. Doesn't matter if you say reference equality or context equality, doesn't matter. And now if I say x dot equals y, it should, if and only if, which means if I say x is equal to y, then y is equal to x must be the same case as well, right? Finally, transitive. Okay, it's like this. If I say I is larger than j and j is larger than k, what does that mean? I is larger than k, the same idea. If I say x and y are equal, and then y and z are equal, then x and z must be equal. Okay, that's transitivity. Okay, and you can definitely go to this page over here, API for equals, and there's something to do with hash code, which we'll talk about after lab test, so you don't have to worry about that part yet. I do encourage you to go to the API for equals and have a look. Okay. So now, what I would like to do now is to show you version number 2. Okay? So for the way you define the equals method, it's a little bit tricky the first time you see it. There are basically 4 stages you have to do the comparison. Stage 1, stage 2, and stage 3 are always the same. Doesn't mean you have to memorize. I'll give you the fragment of the first stages pretty much for the lab test. So you don't have to memorize it. Just the critical part you have to remember. Okay? But the 4th stage is really about how you customize the equality between your 2 objects. Okay? So we'll go over them. And there's certain detail about how you define the equals method which will only make complete sense once we talk about inheritance and polymorphism and dynamic binding. So I'll try to explain as much as I can, but if you can just keep asking questions. Okay, let's see over here. Let me just show you how the code looks like, and then we'll have a look together in detail in the iPad. First of all, we have to say for point V2, so now we explicitly redefine the equals method over here. Okay? And then, oh, actually all the 4 parts are here. Okay, let me just switch to iPad. I think I should. Okay. So now what I want to do is, so this version we have seen already, that's a V1, okay, V2. So now let's go over step by step. So now this is the complete definition This is a complete definition for equals, but let's look at one line at a time, okay? So now let's look at this line here. I'm going to highlight that for you. Does this line make sense to you? We say that if the context objects equals the other object as the input, then that means they must be equal no matter what, return true. Make sense? Yep. Let's see one example here, okay? Let me ask you this. Remember we talked about transitivity, reflexivity, and symmetry before, right? What can this satisfy? When I say if this equals object, it must be true. Which one is that? Transitivity, reflexivity, or symmetry? Reflexivity, right? Because x dot equals x must be true. In this case, we are saying that if the context object equals has the same address as the other, the input must be true. Let's see one example right away. The example would be, let's say we got P1 here, we got P2 here. They are both of type point V2. Okay, over here, when we say P1 dot equals P1, that should be true without any surprise, right? You can see this case over here, P1 equals P1 would be exactly true. So that's how we satisfy the first requirements. Okay, that's the first step. And first step is always the same. First of all, before you do anything else, check to see if the input you're getting is just the same as the context objects by reference. First step. What I will do in the lab test, I'll basically give you the if branch over here, but I will get rid of this value and want you to know what you should put there. Hopefully that's logical for you to infer, right? You don't have to memorize, but hopefully it's just logical for you. Okay, that's about first step. Any questions before we go to second step? Okay, second step. Similar to what we said. Second line over here. If object is equals null, then we return false. The same question again, if you don't mind. What if this is also null? Can we not return true? What if this is also null? You are forbidden to answer. Anyone want to try? This half? Want to try? My question is, let me state again. My question is, why can I not say if, of course, if object equals null, it returns false. I'm a little bit questioning about this. What if this is also null? Object is also null. Then I should return true, right? Agree? Yep, sounds logical, no? No, does it sound logical? Oh, well, yeah. Because you say yeah, right? So I thought you agree. So, okay, if you don't think that sounds logical, I thought that sounds logical, then explain to me why not. So let me say it again, even more precise. Why can I not say something like this? If this equals null and obj equals null, return true. That's my question.
Because P1 is an object that exists. It's already not null. So to compare it with null, it's false.
Well, what's P1? OB, not really, not exactly what but you're getting somewhere, okay. I would like to hear the keyword, yes. It should crash. Yeah. Why would it crash?
Because object is null, so you're evaluating a null value.
Okay, how about this? Basically, I'm asking the following. I'm asking the following question here. I'm asking, can I write something like this? If this equals null, and obj, the input equals null, and then, and then I'll say return true. Like that. That's my question. Okay? So now the answer is no, you don't write that. Okay, there's a reason. So basically, if this branch can ever be executed, it means the following. That means I say x dot equals null. At the same time, x also is null. When we say null dot equals null, will we actually even get to this branch? No. We got prevented from null pointer exception already, right? That's why. Okay, be careful if I ask you this question here. I want you to explain exactly to the point. Okay?
Can you re-explain that?
Of course I can. Of course I can. Let's try again. The question was, why can I not say if this equals null and object equals null, return true inside the equals method? That's the question, right? Let's say we expect this to happen in some cases. If this does happen, that means the x we are talking about is simply just null. And also the input value is also null, right? And we thought in this case it should return true. But do you ever get to the body of the method though? No, right? Because null dot equals something, null pointer exception. You don't even get there. That's why you don't even write it.
So like when we actually write that in our program, and we say x dot equals something, and x does not exist, it will just like this.
It's just like a null pointer exception.
Okay,
Yeah.
great.
Yeah, that's why we part of the review, right? Where every time when you're trying to use a dot notation there, x dot equals something, you better make sure x is not null. Yes.
So if that happens, why do you even have that if statement?
Which if statement?
The object equals null.
Object equals null. Oh, because, okay. The question is, we say that the orange one over here is not necessary for a reason, because you might just get null pointer exception anyway. Okay. Now the question back is, why do we need this line over here? It is because you might have something like that. Oh, let me just show it to you. Let me highlight this line for you. P1 dot equals null. This is certainly possible. You can see P1 is over here. It's just some new object over here, which is not null. So we don't get any null pointer exception. So now when you say P1 dot equals, you can just pass something that's null. In this case, you should also really give a case like a return false. That is why. Okay, so guys, do review these cases I talk about carefully. Okay, you should know what's necessary, what is unnecessary. Okay, that's my point. Okay, any question about step 2? Yes.
For the first case, just to clarify, it's like if x was null, that means like
Null pointer exception.
because there's like nothing there. Right?
Yeah, exactly. When you say, let's say this, if x dot equals null, but x is also null, that means this x doesn't even exist. So where do you find the object to call the equals method? So it will just give you a null pointer exception. You never even get a chance to execute the equals method. Okay? It's something that happens even before that. Okay? Okay, no, let's go to step number 3. Any more questions? Are we okay? Number 3. Okay, number 3 over here. Let me explain in the following way, okay? Let's just read the read over here. This is what we say. Oh, you know what? Let me draw a little bit better. Like that. That's the line. This, which is a context objects dot get class, not equal to obj dot get class. Okay, what does that mean? So let me give you a little bit idea over here. Okay, when we say get class, let me just give you the precise name for that. You should definitely review this part of the iPad maybe after we talk about polymorphism and dynamic binding. Okay, let me put it here. So when we say get class over here, what it will give us is something like that, dynamic type of this particular objects. Let me give you one example over here. Let's say over here, if I say P1 dot equals S, P1 is a point V2 objects. S is a string. Okay? When you say P1 dot equals S, it compiles, nothing wrong with that. However, in this case, think about, okay, how do you think about dynamic type? In this, as far as now is concerned, I would say draw a diagram very quickly. I'll show you what dynamic type really means. How do you draw this line over here? P1 is equal to some new point P2. We know that it's going to be P1. It's going to be, oh, that one's bad. Okay, over here, how do we draw this line over here? P1 is pointing to some point V2 objects, right? That's how we draw the objects. On the other hand, S over here is pointing to some string objects, right? That's how we draw the objects. Basically, what the get class would do is exactly the title of the boxes. dynamically. Okay? I will talk more about dynamic type when we talk about inheritance. But for now, just think about what's actually happening for each object over here. For S, it's pointing to a string object. For P1, it's pointing to a point V2 object. You're basically comparing banana with apple. They cannot be compared. Right? In this case, return false. Okay? Let me just do one more thing for you. Basically, what you will get is P1 dot get class will give you point V2, okay? And then S dot get class will give you string, and they are not the same, okay? And then, but for this expression here, I will always give that to you in the lab test. There's no need for you to memorize, but you gotta understand what it is doing. Okay, we're saying that if you're comparing two things, they're actually not the same type. Well, return false. Yeah, step number 3 may be a little bit not so clear, I agree. But since you haven't learned about dynamic type, so that's all I can say. Okay? But you can still ask questions. Any questions about this? Yes? No. Yes. You know what? I think type and address are different. Okay. The question was, when I said these two are not the same types, it simply means the title of the box, they're simply fundamentally the object structure is different. Because for each point V2, you got X, you got Y. But for string, you just got a string value, like the component characters. So there's different structure. But when it's a different addresses, another issue over there. Okay. Okay, that's about step number 3. Okay, step number 4. Yep.
The middle one, the printing P1 dot equals S. What if this is not one equal but 2 equal?
2 equal sign. Oh, good question. The question was, this will compile, but it will just give you false, right? The question was, very good. I like that question. The question was, what if we say P1 equals S? Okay? So now, tell me your intuition. Do you think this will compile? Well, in some way, if you think a little bit more naively, you're basically comparing two addresses, right? But you're comparing address to apple, address to banana. Java tell you, no, you cannot do that. Okay? Basically, P1 is the address to point V2. S is the address to string. You just cannot compare them. This will be a compile time error. Very good question. So this one here will not compile. Okay? But this one here will compile but give you false. Okay? Okay, we gotta talk about 3 steps, and now 4th step. It's a little bit, yeah, let's try together. Okay, so now first of all, if you can reach this line, which means you haven't returned from here, you haven't returned from here, and you haven't returned from here. So what does that mean? If you can actually reach this line, that means OBJ is not null, and also they are not the same objects, and also they are of the same type, right? Up to now. But now, the thing that's a little bit ugly is over here. I'll try to explain again. How does it look like to you? If you just look at the syntax, how does it look like to you? We did something similar to primitive types, especially numbers. Do you remember the name? Cast. We usually used to say you can cast a double into integer. Now we're somehow casting something to point V2. It's something called typecast, which we'll address thoroughly after reading week. Okay? But now let me explain to you the issues over here. Try to see how much you can digest. Okay? If you really cannot make any sense of what I'm going to say for the next 5 or 10 minutes, that's okay. You just make sure this line over here, I'll give that to you in the lab test. Okay? Okay, let's try the following. Let's try over here. I want you to first of all look at this line, this fragment of code here. Object OBJ. Okay, So first of all, you can see that over here, what am I doing here? I am declaring a parameter variable called obj. Its type is objects. I'm declaring. So I'm now at the point of declaration. Oops. Declaration. Okay, so far so good. I'm just declaring the type. At the whenever you're declaring a type at the declaration time, is something called static type. Okay, something similar over here. When you have this declaration over here, I'm declaring P1 to be of this type. Over here, I say that this is the static type of P1. So static type is easy. Whatever you declare the variable to be statically, that's static type. Okay? But now, the problem is about dynamic types. Okay? I want you to look at this. Okay? Can we have a look at this? What about here? P1 dot equals P2. Look at this line. When I say P1 dot equals P2, okay, you can see over here, P2 over here is the input to obj, right? Remember I talked about dynamic type? Let's draw the picture. How does P2 look like? P2 basically is pointing to a object over here of type point V2, right? That's where we declare. Okay, so point V2 over here is of type point V2. So that's the dynamic type. So this is the dynamic type. Dynamic. Okay, so now when I pass P2 as obj, right? So obj is now also pointing to this object here, right? Right, that's what I'm doing for argument passing. So now here comes the tricky issue over here. Obj specifically has two different types. And let's see exactly what's going on over here. For obj, let me just write it here. For obj, it has static type objects. That's where it is declared. Static type is objects. On the other hand, it was assigned to this particular input of type point V2. That's so-called dynamic type. And point V2. Okay, so these two types are different. So what's so wrong with that? Okay, let's try something which wouldn't compile. Let's see this. Let me just go to the next page over here. Okay, let me just say it again. We know that we're going to replace this by P2, and P2 is pointing to some point V2 objects over here. So this is the dynamic type, and this is the static type. Okay, just a recap from the previous one. So now I want you to look at this line over here. This line, where we do the cast. Temporarily, if you simply get rid of this line, temporarily, let me say I cross it out. I simply say return this dot x, obj dot x, this dot y, obj dot y. I know that obj is also pointing to point V2 object. And remember point V2 does have x and y, right? I want you to stare at this line of code a little bit. So I'm talking about a hypothetical scenario where we didn't have the typecast. And I simply say return this dot x equals obj the input dot x. And this dot y equals obj dot y. It makes intuitive sense. However, it is not going to compile. That's where the tricky part is. Okay, let me say again. So this one over here will not compile. So here's the reason. Whenever you want to see, let's say I say obj dot x and obj dot y. So you have to understand a little bit about how the compiler determines if things should compile or not. Here is how they determine statically. When they look at obj over here, they will look at what their static type is. What's the static type for obj? Objects. If obj.x should compile, that means the x attributes must be declared in the object class. Is it the case? No. Remember, x is an attribute for point v2. It's not an attribute for objects, so you wouldn't compile. Okay. However, obj really is pointing to a point v2 objects, but somehow the static type restricts the way you can call methods on the objects. Okay. Let me write it down very quickly. Obj has static type objects, which means it cannot call attributes or methods defined in its dynamic type, which is point v2. Okay, we'll definitely revisit this line later. Okay, so now I'm just telling you, if you just get rid of that typecast line, it wouldn't work. It wouldn't compile for this reason. But let's say once we put this cast back. So what are we doing here? Once we put this line back, we're telling Java that we are pretty sure obj is really pointing to a point v2 object. It is really pointing to there. So just do a cast for us. After that, we can definitely say the other is a new variable here. We can just use other to call the x and y. That's actually specific to point v2. Yeah, okay, question first, and then before I tell you why you should know for lab test.
Oh, so like, what if we change the green circled object into point?
You don't want to do that, because remember what we wanted to have before. The question was, what if we simply change the object over here to just point v2? The answer is no, because remember we wanted to cover a case like this. We want to say p1 string. We want to really compare any two objects in Java. We should always return either true or false. We don't want to restrict what objects we can compare. But now in this case, if you change that to be point v2, that means this line over here being passed as string, we can compile anymore. So that will restrict our way of using equals. That's not good. Okay? Okay, guys, any more questions before I tell you what you should know for the lab test? How about that? Okay? As I said before, for this fourth step here, it's difficult since you haven't learned about inheritance, polymorphism, and dynamic binding. It's simply because of that. Okay? You don't have enough knowledge yet. But as far as lab test 1 is concerned, this is what I need from you. Okay? Let's have a look at this. I will basically give you lots of skeleton over here. I'll remind you, you should always check this condition here. You should always check this condition here. You should always check this condition here. These three conditions over here, you do not memorize them. I'll give them to you. All you gotta know is what should be the corresponding value logically. Okay? That's all you need to know. On the other hand, for this cast over here, I wouldn't worry if you don't understand fully for now. I will also give you something very similar to remind you. Okay? Basically, what you gotta do is, whatever class you're dealing with, just put the type inside the parentheses. That's all you gotta remember. How about that? And for the rest of the syntax, I'll give them to you. All you gotta do by yourself is about how to encode the logic about if I got two point v2 objects, how do I compare if they are equal? In this case, I gotta say this dot x equals other dot x, and also this dot y equals other dot y. That's all you are expected to write for your lab test. You will see similar example for the birthday book. Okay? Questions? Yeah.
You said that line will never compile.
Object equals no, you will compile. It's just the second step.
But like you said that because if object is null, then it didn't get null pointer.
No, it's different. I'm saying that you should. Well, it's okay. The question was about the previous discussion here. The question was, if you, so this over here, if you don't really need to have this. To say this equals now, and obj equals now. That's something you don't have to say. Because if the context object is now, you wouldn't even get there, right? You will compile, just unnecessary, okay? Okay, that's about equals method. Let's see example here to emphasize my point. Okay, let's now talk about equality for person. Okay, let's go over them together. Yeah. So we still got about hopefully 10 to 13 minutes, roughly. Okay, how do we define the equals method for person? Let's look at them together, okay? Let's have a look at them together. So first of all, you can see we just redefine this method here, okay? And then we say if the current object, well, you can see all the first three cases are really the same. I have a little bit challenge for you, okay? Before I say that, over here, second case, second stage, and third stage. Okay, so these are the two cases, right? Now, I combine them into a single one. Because this returns false, this also returns false. Logically speaking, I can say if either obj equals null, or this .get class not equal to that, either what happens, you should return false. Okay, so it can be simplified. But this one is up to you. If you want to simplify, feel free. And then I do another cast over here. As I said before, all you got to remember is whatever you put over here should be the same as the class you're defining. Okay, after that, we can say, now we can just use other. Okay, you can see we just use other over here, other, and also other and other. Okay, so what, let me finish this and I'll take your question. So what does it really mean for two persons to be equal? That simply means their weights, heights, first name and last name are equal, right? Over here you can see the equals method over here, equals over here, is simply calling the equals method for the string objects, okay? From string. Because first name is a string, last name is also a string, okay? So you can really reuse the equals method whenever necessary. Okay, questions before I go to the next one?
So the person cast is going to be the same as the class that you put in front of other.
Correct.
Right?
In front of other, yes, correct. Yeah.
If statements instead of if and then else if.
Oh, okay. I think it's just the way we write it. Basically, okay, the question was, okay, two questions there. First of all, you can see the person over here, and the person over here, and the person over here, they always match for now, okay? The second question was, we only get if over here, if over here, but we don't have else if. The reason is, we want to say, if this is the case, we just return true. If this is not the case, basically it's like a if something over here. You know what? Let me think about it. I'm pretty sure you cannot do it. Let me think about what would be the best way to explain this. I'll mention that in the beginning of Wednesday. That might be better.
Because I know it never exits it. It just like checks for the first one, then checks for the second one. But
Yeah, basically you will check for the first one. Okay, currently, I'll try to explain to you why the else if may not be desired in this case. I will try to explain to you in the beginning. But currently, we'll start with this. If this is already satisfied, we return and then we exit from the method, right? If it is not satisfied, we go to the second one. That's how the logic goes. Okay? Let me try to find out what's the best explanation for you for else if. I'll try to do that next time. How about it? Let's not waste time. Okay, guys, any question about the person equality before I go to another one, which you will need for birthday book? Okay, I better go through that one as well. Okay, let's say this. We have a class called person collector. The person collector is a little bit like a point collector. The person collector has an array of persons. So what does it really mean for two person collectors to be equal? That means, first of all, they must contain the same number of persons. And also, the person object at position 0 in the two person collector must be equal. And the person at position 1 for the two person collector must be equal as well, like a position-wise equal. That's kind of the idea. Now, how do we code this up in Java? Let's have a look. Again, the first 3 steps are very similar. Okay, let's have a look. So now, first of all, you can see that we got person collector here. We have an array of persons and also number of persons, right? You should be very familiar with this pattern here. That's also one of the required readings for lab test 1. Okay, we have a person constructor, also add person mutator. Let's have a look at the equals method for the person collector. First of all, you can see that, let's see the routine. If this equals object return true, the same. If either obj is null or they don't have the same class at the runtime, that should be false. And right? And then we'll do the cast over here. And the cast will be this class over here, the thing we cast into, and this class that we're talking about should be the same. Okay, the same pattern. I promise I will explain this line in full detail after reading week, but not for now. Okay, so now this is the part you have to code up. One very common mistake. Starting from here, I want to emphasize that very hardly over here. Okay, over here, do not mention obj, because you have already cast obj into other. Only use other, because you can see over there, whenever you talk about other, for example, other.nop, right? Other has been cast into a person collector over here, which has the NOP attributes. That's why you can use it. If you simply say, for example, obj.nop, that wouldn't work, because obj was declared to be of type objects. Object does not define the NOP attributes, right? Only the person collector. Okay, so this would not work. Okay, something to warn you about. And now this is the loop. Hopefully that will make sense to you. I just declare some Boolean variable over here to be initially false, and then we say we start with 0, and then as long as we haven't found it yet, okay, as long as it's equal so far, and then you know what? There's a typo. I think this should be true. I'll fix it. It should be true. And then I is less than this.nop. We have talked about this pattern here. And then let's look at this line here. Look at that for 10 seconds before I explain to you. This.person's I. Let's go one by one. What's the type for this.person's I? It's a type person. Agree? And then what's other.person's I? What's the type? Also person. So which version of the equals method will be called? Would it be in the object class or in the person class? Person class, because we override. We already redefined the equals method. So this is what I would recommend you do. However, let me show you the alternative way of doing it. So over here, we're simply calling the equals method from the person class. It is as if we did the following. We said this dot persons at position I, for example, dot first name dot equals, and this equals is from a string. And over here, what we put is other dot persons at position I dot first name. And you got other attributes to go over, right? Because you can see that over here from the definition for the equals method for person, this is so many comparison of the attribute you have to write. But now by calling the equals method over here as a helper method, we're basically reusing the same block of code for the equals method. Okay? From the person's class. Okay, any questions about this? Yes, that's already fixed the typo in the slide. It should be person collector. So there was a typo here. I already fixed that in the slides, but this should be person collector. But guys, any question about this equals method here? Okay, I would say, yeah, that's certain things you have to understand the logic, but the typecast, don't worry too much about it. Just use the way it is. I'll explain all the rationale behind the typecast after the reading week. Any questions before I call it a day? Okay, I'll tell you, I'll upload the slides, but equals method is done. Okay, and then that will be the end of the lab test 1 coverage.